So I'm going to talk about two things that I'm passionate about. One is energy and the challenges around sustainable energy, and the other one is innovation. Sustainable energy is about the challenge of transforming the global economy from where we are today to where we'll be in 2050. Energy is fundamental. We can't do without it. Virtually every aspect of society relies on energy, and if you don't have it, it almost certainly means poverty. So this is where we are today, or in 2014, which is the most reliable recent data we have. So they're saying that global GDP will go up by almost 3 times. And so the question is, what do you think will happen to CO2 emissions? Has to go up by an enormous amount. And basically we're going, in many parts of the world, from very low living standards, very low electricity use, to an urbanised world like Jakarta, only more. And to do so, we need to invest roughly $350 trillion in infrastructure. And of that $350 trillion, we think 20% or a quarter might be on energy infrastructure. So that means, over the next 35 years, we're talking about investing something like $70, $80 trillion in energy infrastructure. So the energy sector is going to be a really interesting place to be for the next 15 years because A, we're going to invest all that money, and B, we've got to do it very differently to the way we've done it for the last few decades. So in other words, we end up in 4 groups. Climate change is not urgent. Fossil fuels are not hard. Who lives there? So people who live in this box tend to be advocates for nuclear energy and renewables who say it doesn't matter whether climate change occurs or not. The next group is here. And they say 2 degrees C is easy. It is just entrenched views and political slowness that is stopping us from doing this job. Up in this other corner, though, is people who think fossil fuels are hard to replace and climate change is not urgent. So in other words, they say, why do we need to change? Many people in society actually think this. And then finally, I think it's urgent, we have to do something, but at the same time I think it's really hard, and in fact, you'll learn through the course of this, I think 2 degrees C is impossible. The fact that the majority of the people live in those 2 quarters is what I've found actually is a problem. We are here today with a whole range of current energy systems. There are lots of natural resources invested. There's lots of technology that's entrenched. We understand it, we use it. There's lots of human capacity to do these things. And we've got to go to this future energy system and we've got to adapt our resources, find new resources, get new supply chains, get new plant and equipment invested, create new manufacturing facilities, develop new skills in our humans. And we have to change all of these things. Electricity sector, heating and cooling, transportation, and industrial production. All of these are very, very significant energy users. And if you think about it, it's a massive investment in infrastructure we're talking about, and changing all of this global infrastructure in an extremely rapid pace. But the industries I've mentioned here, which are deeply reliant on energy, defence, agriculture, aviation, freight, land freight, shipping, secondary production, so manufacturing, and primary production for exports. Yet today, I think the progress is disappointing. That's a picture of the global energy, the use of energy resources in 1995. Now spot the difference to 2014. 20 years on, since we decided we have to take action against climate change, what's the main thing we did? The total, we're using more. So incrementally we've moved the percentages around, but the main thing we did was use a lot more. We have 1.6 terawatts or 1,650 gigawatts of coal. So more than 1,000 gigawatts, more than 1,000 new coal-fired power, big stations, big plants, under construction or planned today. So despite the fact that we all say we should, well, many people say we should be able to move away from fossil fuels, the evidence is not there yet. And to prove it, this is the growth in greenhouse gases. Over the last 40 years, the last 10 years was significantly worse than the previous 30 years. We talk about action, but the evidence is not there to suggest it's happening. And part of this is the scale problem. There's just too much energy that people want. This is the truth, and that we don't currently have a solution. And too many economists and too many policymakers think it's simply a matter of some market thing. We clearly don't have what we need today, and therefore my hypothesis is we need to innovate. The energy sector needs a very strong innovation push, and hopefully some of you students are the future of this. Why innovation is critical here, the main energy solutions we know. When it comes to CCS, we've got a public acceptance issue. Intermittent renewables, availability, so your sun's not shining, you don't have power. The cost is still high, and the ability to scale rapidly is difficult. Dispatchable renewables, again, infrastructure, public acceptance and cost. So this is hydro in particular. There are limited hydro options in the world. Nuclear, how do you regulate? What's the risk of weapons proliferation? The public is against nuclear. Some places you can't use nuclear because of the risk of earthquakes, and it's costly. The last one, being more efficient, managing the demand side use, to me is a no-brainer. I want to have a word on energy access for the poor because it's a significant issue in Indonesia. 1.3 billion people in the world have no electricity. Another 2 billion have very unreliable, limited access. And 2.7 billion have no clean cooking fuel. So this is people who rely on gathering wood from the forest. We're talking about 40% of the world's population. This is a huge problem. So one of the issues with this problem, this is people in India searching for firewood in order to use for cooking and for heating. It's all done by women and children. So women in India, and in parts of Indonesia it turns out, spend up to 5 hours a day gathering fuel for cooking. So it has enormous impacts on gender and family issues and therefore on the whole productivity of society. Another stat, 4 million premature deaths per year in the world due to indoor pollution, because these are very toxic smokes. The 4 million are almost exclusively children, is the biggest killer of children after malaria. So this is energy poverty. The issue of resolving energy poverty, for me, is perhaps the greatest challenge for climate change. And I'm going to show you a curve. The interesting thing here is the richest 1 billion people of the world, largely the richest, emit more than 10 tonnes of CO2 per year. And the poorest 3 billion of the world emit less than 1. What's going to happen in the future? If the poorest in the world increase their emissions to even below the average of the world today, then we will put almost the same number of emissions into the atmosphere as is occurring today. So we will double emissions. The lowest cost way to provide energy for those people is through the traditional forms like coal-fired power. And so how do we resolve this dilemma? So I want to talk about some game changer trends that we're seeing in the energy sector. And these are game changers in the sense that they are environmental or political or social trends that are going to force us to change the way we do things. And these have huge implications. So some of the things we see is we see business models being disrupted or even destroyed. We see assets being stranded, that is, assets which we potentially are no longer able to use. And we see winners and losers. So someone part of society or business is losing from these trends and others are winning. So firstly, the idea of carbon budgets and unburnable fossil fuels. If we are to avoid exceeding 2 degrees C, then we can only emit 1,000 more gigatons of CO2. Is about 2 trillion barrels of oil, about 20,000 trillion cubic feet of gas, or about 300 billion tonnes a year. So roughly, at the current use, we run out of this in maybe 30 or 40 years. Now, how much fossil fuel is currently in the ground that we know about? So oil has about 8,000 gigatons worth of CO2 equivalent. The gas has about 3,000 gigatons of carbon, so we can't burn all that. The clathrates have about 40,000 gigatons, and the coal has about 20,000 gigatons of CO2. So this would suggest that if we burnt no more oil and no more gas, we could only burn 5% of the coal that's in the ground. So examples of carbon lock-in. Carbon lock-in could occur where we have large coal-fired generators have a life of 40, 50 years. They have high capital and they have low operating costs, and they're carbon intensive. Another example is the high voltage transmission and distribution system. Motor vehicles. What happens to motor vehicles that are invested today, but then in 15 years, due to either pollution or due to climate change, we decide that all vehicles will have tighter emission standards. Buildings. New buildings that we erect today, but which are subjected to future building efficiency standards. Energy subsidies which cause overconsumption of fossil fuels. The reality is all of these affect Indonesia. I mentioned before about the carbon budget, and basically, I want to show you what 2 degrees C means. So we really accelerated fossil fuel use from about 1940, and it wasn't linear, but it's near enough. So from 1940 to 2020, we will emit 1,600 gigatons of CO2. If we are to achieve a 2 degrees C temperature rise, we have to go from, by 2100, emit another 1,600 gigatons and no more. So we have to peak in 2020 and then go down at the same pace. So that's what we actually have to do. So what it actually means with all the coal-fired power plants we're putting in today, it looks more like this, I think. We put another rectangle in here of 1,600 tonnes, but instead of being a peak at 2020, it's a plateau. And then sometime around 2050, 2060, the world becomes very uncomfortable. Crops are failing, and the impacts of climate change are becoming very serious, and then we decide to do something. And all the commitments that have been made so far, at Paris as well, suggest that. And the point is, even that reality leaves a lot of fossil fuels in the ground. Okay, we've already seen that, and I've already pointed out your country is among them. Now I want to ask you a quiz to see what you know about which country had the greatest percentage increase in total energy use over the last 30 years. Thailand, 750%. Okay, which country had the greatest percentage increase in electricity use in the last 30 years? Who, sorry? Vietnam? Vietnam. 2,500%. Okay. Which country had the greatest percentage increase in coal usage in the last 30 years? 21,000%. If I add the populations of those three countries, I've got a population bigger than the United States. So the power of this group of countries is that if it develops in the same way as the United States, for example, then we are in trouble. So that's the point of this little quiz. Another game changer that I want to talk about is the idea of a new kind of electric company, where you have a business or even a house which is a producer of electricity. Now we have the consumer of the electricity also producing the electricity. And for 4 months of the year, they were covered in snow. So where did they get their electricity in those 4 months of the year? From the grid. So on the one hand, they produce more than they use over the whole year. On the other hand, there are many times of the year when they need coal-fired power stations. So what's the implication of this for traditional business models? I've invested in the grid on the basis that many customers will buy the electricity from it and I will get a return. Suddenly, I have some customers who actually don't buy it from me. They produce more than they produce more than they consume. So in fact, they earn money from the grid. Therefore, as the grid owner, I've got less customers to pay for the asset that I invested in. So I'm losing money. And it's not just isolated cases. So this is a really interesting graph, the idea of decoupled economic growth. This here is US electricity use per unit of GDP over 40 years, that's over 80 years, a forecast. So this is the growth in electricity use. So it used to be growing, and now electricity use more or less flat going forward, the growth. This is GDP. Used to be growing up towards 6%, now growing at 2.4%. Now, Indonesia's not like this yet, but it will be. Now, I think I've been giving you the opinion that I'm not very confident about the global transformation to a low-carbon economy. I'm confident that we'll make a transformation. I don't think it will be fast enough, and I don't think it will be deep enough. But a lot of people say to me, Paris changed everything. So we had this historical agreement to limit climate change, hold the increase of global average temperatures to well below 2 degrees C, and to pursue efforts to limit the increase to 1.5 degrees C. And, you know, everyone thinks it can be done. That's really the summary of where we're at. But I was optimistic on one front, and it's not about the commitment to keep temperature below 2 degrees C, but it was for a thing called mission innovation. So for the first time, people got up and said, we need to massively increase our investment in innovation in energy because the challenge is enormous and urgent, and that it can't be achieved without massive transformation of the entire economy for which new technological advances are required. This is the first time that we had major economies and major corporations and government leaders saying out loud that this is really hard and we don't know how to do it, and we need a lot of innovation and we need technological breakthrough. It won't be easy though, because to do innovation, long-term investment, very long-term investment, lots of risk of failure. Indonesia, countries like Australia, will need to develop an innovation culture. It's going to require lots of collaboration between industries, along supply chains, between countries. And you need really long-term stability in policy, and you need to set the targets beyond 2030. And it needs to be done on big scale, trillions of dollars of investment in innovation. That's my talk on the energy challenge. It's the first part of the talk. But the message is, it's a grand challenge, one of the hugest challenges society faces, and lots of technology, economic, social, and political dimensions.